Let's talk about infusion time and completion time. So whenever you have to do an infusion, you need to know when the start and stop time will be. So let's look at this example. It's at 13:15. That tells me that it's 1:15 p.m., right? And the nurse starts this Dextrol 5 water at 1:15 p.m. And the order was 1,500 milliliters IV to run at a flow rate of 125 milliliters per hour. So you're not giving how many hours they're going to actually do this infusion for, so you have to calculate it. And so we know it started at 1:15. We don't know when it's going to end. So let's set a time, because you can't just pump it all at once in 1 hour, because there is a flow rate you have to set it at that would be safe for a patient. So what I'm going to do is I'm going to take the volume of the IV bag, or the volume that was said that must be infused. And we're going to take the flow rate. Well, when you look at the flow rate here, I'm going to use the the formula method, desired over half times quantity. So what I'm going to do is determine what part of this flow rate is H and what part is quantity. Well, the H is what's going to reduce here. See, the milliliters reduced. And Q is going to be what we're solving for, and it's going to be my time. So now when I look at it, what happened? My milliliters reduced, right? So now I'm left with 1,500 divided by 125, and that gives me 12 hours. So for the next 12 hours, they should be infusing this. Now, remember, sometimes something happens and you have to restart it based upon what's left and however much time you're supposed to infuse for. So you got to watch for that. However, in this case here, we know we're going to infuse for 12 hours. Now, what does that tell me? I want to know when will it be complete, if and only if nothing interferes with it. So let's rewrite this back into the 24-hour clock. Let's take the 12 hours. And remember, in a 24-hour clock, the first 2 digits here is hours, the last 2 are minutes. So since we have 12 hours, 0 minutes, we're going to set it up that way. And let's add it up. So now it says 25:15. However, we know that there's only 24 hours in a day. Some of you already saw the answer before you had to do all this. Now we're going to subtract the 24 from the 25:15. And this gives me, so at 12 hours later, which some of you already knew, 12 hours onto 1:15, what it puts you at, but this is good. So if you were asked to write it in the 24-hour clock time, or the military time, or international time, we know it's 1:15. In standard time, we would write 1:15 a.m. Now remember, the first 2 digits of this 24-hour clock, if it is 12 or greater, 12 to 2400 or 24, we know it's PM. If it's 0 to 11, it's AM. And that's why you do not write AM or PM with this. So our answer is 0115, and standard time is 1:15 a.m. Now, let's solve for flow rates. So you're given a drop factor. A drop factor is the tube that's running from, so if it's a gravity drop, this is what the drop factor is. It's running from the IV bag to the patient's arm. You can change the IV bag, but you're not going to change the needle and the hose that's hooked up to the patient. So this does not ever change. The drop factor does not change. So now what I want to do is determine what my flow rate is, right? And you're giving 250 milligrams in a 50 milliliters. So this is my volume that we're working with. And then the IV bag, the strength of it is 250 milligrams. So we call it dosage and strength. Anyways, so it says the Dextrol 5 IV piggyback. So that piggyback tells me they're adding it to the IV that's already been infused. So they're already got some kind of infusion going on, and they're going to come and add this antibiotics, and they want to do it over a 30-minute period. Okay. So what I need to do is to know what is the flow rate need to be during that 30-minute interval of this here. So I'm going to take that 50 milliliters and I'm going to put it over 30 minutes, because that is what we're administering. We're administering the volume over that time. Remember, the 250 milligrams has been taken care of inside that 50 milliliters. And I'm going to multiply it to my drop factor. And what do I see here? I see that the milliliters reduce. Now, if you want to reduce here, go right ahead. If you want to multiply straight across and then do it, it's up to you. I see, though, that 15 goes into itself and goes into 30 twice. And when I do this, what do I have left? I have 50 divided by 2. And that tells me, I mean, that's just 25 drops per minute. So my flow rate with this IV piggyback is going to be 25 drops per minute. And it's got a fusion time of 30 minutes.